Hello, welcome to SolEpoxy. My name is Caitlin Penston and I'm the quality manager here. So it actually started after World War II. An American soldier came back with some formulations of the first epoxies that they found from the Nazi Germany soldiers. And they were able to take some of those formulations, bring them back to Olean, and then after years of trial and error, they actually started with the first, what we call the dry coat. So it was a solid B-staged epoxy, and it actually was brought here from Europe after World War II. We have about 70 people. There is about 30 manufacturing personnel, operators. They operate fork trucks, they receive in the material, they move material around the factory, they ship it out the door. We have other operators that are very specialized in different areas. And then we have maybe a technical team of about 15, 20 people. A management team is maybe about 7 to 10. And then an office staff of the remaining, maybe 15 or so people.
Hello, my name is Mary Deegan Collins and I'm the production manager here at SolEpoxy, and I will be your tour guide for the production area. First I'm going to show you our display case and what our materials do. It's kind of hard to describe our materials because we don't make a finished part. We're making powder and pellets for leaving here. Our material leaves SolEpoxy in either a powder form or a tablet form. But where it gets exciting is what our customers do with this. They turn them into sensors. Other little pieces and parts, it's all electrical or electronic, whether it's covering a circuit board or the top of a Dyson vacuum motor. So we have three main product lines at SolEpoxy. We have our molding compound lines, which are for electrical, electronic applications. We have our opto lines, which is for the LED market, sensors, your blood pulse oximeter that you get at the doctor's office. It may be, it's hard to tell, but this one's blue. It may be colored, it may be clear. Our bottom two racks are our coating powders for small motors, for your windshield wipers or your seat in your car. It's coatings for your alternator for your car. Capacitors, resistors, all those lovely little things that go in all of our electronic devices. One of our big lines is bus bar. Think of this as a wire, which it is. It's copper. They can be 10 feet long. They can be small. It's for getting power through warehouses, windmills, that kind of stuff. If we move to our other display case, it's a little more application-based. So back to our molding compounds. We have power resistors. We have solenoid valves for your gas pumps. Film capacitors, which is this one's used in the music business. We have armatures, which were over there. Diesel fuel injector. I already did the blood pulse oximeter. The fan looks kind of funny sitting in this display case, but the motor inside is coated with our material. More bus bars and high voltage bushings for lightning arresters and that kind of thing. And that's essentially how our customers use our material. So this is our raw material warehouse. Essentially, SolEpoxy is a straight-through factory. Our materials come in this end of the building, get processed as we go through the building, and exits at the other end of the building. As you look around, it takes an awful lot of raw materials to produce our materials here at SolEpoxy. From resins, fillers, epoxies, catalysts, pigments, all that stuff, just, I don't know, is everything we need. We're going to keep Keep coming this way. As our raw materials come through this end of the building, they sit in these big old red boxes right here. It's our quarantine area. So when it comes in, we take a sample, take it to quality, test it to make sure it's good for our customers, and then we come out and label it. All of our raw materials, I need one that's not upside down, get an approved raw material label. This is how all of my operators know that the material is approved. It gives them a stock code, its expiration date, and a batch number, and any health and safety information that they need to use this material. So that's essentially our receiving warehouse. So we're going to show the process of manufacturing from beginning to end. First, we got to go upstairs to our pre-blend area, down to our extrusion, and then we'll move through the factory. This is our pre-blend area. We have two different style blenders here. We have a ribbon blender, which is a horizontal style blender, which turns with like a ribbon inside to blend everything. As you can see from my operators, everything essentially gets loaded by hand. The blenders actually sit on load cells, so they're keeping track of the material as they wait. Following a recipe, just like you would for baking a cake. And there's also an order for them to follow, so they know exactly what they need and what raw materials they need. This is the other style blender we have. It is not a blender, it's a cone and screw. So there's a screw on the inside that rotates itself, so the material rotates around the outside and it comes up, spills over and blends. So we're essentially in the room below where we were just a second ago. Just to explain the process a little bit. The material, like I said, is all ground. So it's all the same size in like the cone and screw, put in a bin, and then we're feeding an extruder. So we're in our extrusion room. We take the material either in a bin or the big hoppers below the blender that we were in. We feed it through a feeder, in through a feed thing with magnets. Since all our material is in electrical, electronic, we have to go through magnets so we get rid of any metal. And then it feeds into an extruder, comes out like a toothpaste consistency, gets cooled down through chill rolls, goes up a dehumidified and cooled, water-cooled belt, and then it's ground for further processing. So we have 5 extruders in this area, and each extruder's batch is between 4,000 and 6,000 pounds. So we have huge batches for making things as we do. So we have 2 different materials here. We have a green color material, which is used on alternators for the automotive industry. And we have a red material that's used on bus bars. All of our extruders are heated and cooled with different temperatures and different arrangements for mixing. That way we get the consistency what we're doing. Like Caitlin told you yesterday, we make thermoset materials, but we have to react them to a state of cure so our customers can remelt it one more time and get them to be solid. All of our coating powders and molding compounds leave this area, and then from here we split. Our coating powder lines move into this next room, which is fine grinding, and I'll get some samples to show you in a second. Our molding compounds leave this factory in tablets, and that's the department after this. So to show you the fine grinding thing, material leaves the extruder room in bins, goes through a feeder, through a grinder. We have two different style grinders. We have a pin grinder and a hammer grinder. Goes up into a sieving system. If it is too big, it gets back to reground. If it's a good size, it moves on to the classifying cyclone to get rid of any fine dust. You got to remember, our customers are dipping parts or spraying parts. Any of that fine powder they want floating around their factory, so we get rid of it. So essentially, out of the last room, it leaves in chip form. And as it leaves this next room, it comes out in a powder form. So it is custom grind to what our customer needs for their coating applications. This is a pretty noisy room, so we're pretty much walk straight through. But as you see, even though it's very loud in this room, we try to do a lot for noise and sound. We have the yellow and orange sound panels. Our very high noise areas are surrounded in curtains, which is actually bubble wrap. You really get the urge to want to pop it because it's truly bubble wrap. But it actually helps contain the noise, so our operators have a little bit quieter environment. We have and-on boards in our areas to help our operators know what's going on, so they know what rate they're running, what they're running, what's the progress in the last room, so they know what it's doing. And the dark black lines, they give them a target rate so they know what to shoot for that material. Our materials in this room are filled into these cylindrical bins, which go into this tumbler just to mix them to make sure they're uniform before we test them. So we have two different style presses here. We have alpha hydraulic presses and we have rotary presses. The alpha hydraulic presses are for larger pellets. There is a punch in the top, a punch in the bottom, and a die. And as the material, if you swing around, you can see the shuttle box comes out, fills the material die, presses it hydraulically together, and forms it into a pellet. They'll discharge out. It goes across a weight system, so every pellet is weighed, and they follow SBC charting for adjusting their machine. We use a pellet because all of our materials go into a molding machine, and the pellet is the size charge they need to cover their board, their part, whatever. So it's a special size and diameter for them so they can go into their system, where the material is heated up and essentially pressed, similar to what we're pressing here, but it's at temperature, so it flows around their part and totally covers what they need. The other style press we have is a rotary press, which makes smaller pellets. Essentially, as the machine rotates around, it does the same thing, presses them, but it has an automatic rejector already in the machine, so it knows what pellet is bad, and it will automatically reject the bad pellet and the pellet afterwards, just so it's gets the right one. We are in our package area. We didn't really show that much, but you saw red and you saw the lemon lime color. We can make any color under the rainbow. And essentially, we have to clean in between. We do not have dedicated equipment, so anytime we switch colors, it's a complete tear down and clean. Packaging is difficult in the sense that if we had to clean between all the colors, it would be difficult. So we use Mother Nature and gravity to package. Our bins sit up on a stand. They feed through a funnel and another set of magnets, and then all their packages sit on a scale so they can weigh them. We package in drums, boxes, pails, whatever the customer would like for their containers, depending on what they're putting the material in. So this is our finished goods cooler waiting for material to be shipped out to the customer, being broke out in different stages. And we're essentially at the opposite end of the building where we showed all the raw materials. So we essentially have walked through the factory, and now it'll go out the doors to our customers. All of our stuff is stored cold. Some of our stuff is more temperature sensitive, so we actually have a freezer inside of our cooler just to keep things a little bit cooler. We saw an awful lot of equipment today, and we have to have people maintain it. So we're gonna take you to our maintenance shop so you can see what a large maintenance shop and department we have just to maintain all this equipment. So this is our maintenance shop. We essentially have our electrical warehouse and all of our others. Our owner likes to say that our stock rooms have more stuff in them than Wordsmith itself. So we do maintain an awful lot of spare parts and pieces and parts to make sure we can repair anything on the fly. So we have a staff of 5 mechanics and electricians that help maintain our equipment. We do some things we do have to contract out from our local resources of other companies that you might see, Mazza Pierce, Billings, that kind of stuff. But for the most part, we're pretty self-sufficient in our maintenance staff.
Thanks, Mary, for that tour. I'm Kathy Sprong. I work in the accounting department and supply chain. And it occurred to me, we've got a number of other people you probably want to meet, so follow me.
All right.
Hello, my name is Elise Griffiths, and I am the Sales and Marketing Manager here at SolEpoxy. I was born in Cleveland, Ohio, and when I was in high school, I played on the tennis team. I was the captain my senior year, and I also was in marching band. My favorite subject when I was in high school was chemistry, followed by math and physics, so I decided to go for chemical engineering. I got my undergrad degree from the University of Colorado, and I now have my master's in business administration from St. Bonaventure. Go Bonas. On a day-to-day basis, I will reach out to new contacts that I think might be interested in our products and see if we can match up and find something that will work. I also work on developing marketing material to make it easier to understand what our products are, how they operate, and I work with existing customers to help troubleshoot if anything's gone wrong. So with this troubleshooting, sometimes when email or phone calls aren't enough, I'll actually go out and visit customers. This has led me to travel all over the country and actually all over the world. Sometimes with our sales meetings, we meet up with partners who are located in China, Taiwan. It's pretty cool. If I can give you anything to think about when you're deciding what you want to do with your career, follow your heart. Do what makes you happy. If you do that, not only will you never work a day in your life, everybody else around you will be happier too. They'll pick up on that vibe and they will enjoy it as well.
Hi, my name is Eric Rauert. I'm a process engineer here at SolEpoxy from St. Johnsbury, Vermont in the New England area. Loved growing up in New England. And in high school, I did a lot of nerdy things, ultimate frisbee, theater tech, and anything in between. In college, I was a chemical engineer with a minor in polymer science, so working at a plastics company is about where I want to be. And on a daily basis, I use my degree and what I learned in college to solve problems, not necessarily just chemical problems, because engineering is more of a way of thinking, but I'm the key problem solver here, putting out fires and things like that as well. And for anyone wanting to get into my career, I just always encourage you to have curiosity for science, curiosity for math, and take advantage of all the opportunities that anyone ever gives you. Always say yes to exciting opportunities. So.
Hi, my name is Miles Marvin, and I'm an automation development engineer here at SolEpoxy. I went to school for computer science, and on a day-to-day, I'm working on the machines, maintaining them, and deploying new control software.
Hi, my name is Sheila Yali. I'm a process engineer from Ghana. In high school, I liked math and science a lot, so I went to NYU for chemical engineering. So on a daily basis, I'm usually sometimes at my computer, but most of the time I'm out in production talking with operators and making sure the equipment runs right. or I'm in the lab doing experiments. As you can see, my day is pretty exciting.
Hi, my name's Kyle Custard. I'm an R&D chemist here at SolEpoxy. I'm from Allegheny, New York. I received a bachelor's degree in chemistry from St. John Fisher, and I earned a PhD in analytical chemistry at Purdue University. My typical day here at SolEpoxy, I come in, I would make a material based on a formulation that I developed, then I would test parts in order to measure the properties of the material that I've made, and then analyze the data. If it is not what I needed, I will go back and restart the process until I can achieve the goals that I need to for a certain project.
Hi, my name is Phil Ferris, and I'm from Olean, New York. I'm an R&D chemist here at SolEpoxy, and I have a degree in chemistry, and I'm actually right now taking a master's degree in creative studies. When I come into work on a typical day, I'm going to do some work on my computer. I might check emails and correspondence from my colleagues, but I like to do my work here on the bench. I make materials, I invent new materials, and this is where I get to have my fun. A STEM career has offered me a lot of choices. I've been an R&D chemist, I worked as a teacher for a while, and I've done other things along the way too. STEM careers are going to offer you a lot of choices as well. Science, technology, engineering, and math, those are careers that will give you a lot of choices and enable you to go anywhere you'd like to go in the world.
Thank you for coming, and as you see at SolEpoxy, we wear many hats and have many opportunities. So I hope you enjoyed your tour and hope you can come in person sometime soon. Thanks.